Augmented and virtual reality in education, a game changer for learning outcomes. Unlocking the future of education with AR and VR. Executive summary. Augmented reality, AR, and virtual reality, VR, are revolutionizing education by making learning more interactive, immersive, and engaging than ever before. These technologies allow learners to visualize abstract concepts, interact with 3D environments, and participate in realistic simulations that mirror real-world applications. Research confirms that AR and VR significantly enhance student retention, comprehension, motivation, and skill acquisition across various disciplines. Learners are not only absorbing content more effectively, but are also developing critical thinking, collaboration, and problem-solving abilities through these immersive tools. This article delves deeply into the transformative impact of AR and VR in educational settings, drawing from a range of empirical studies and expert analysis. It also offers actionable insights and strategic recommendations for educators, business leaders, and policymakers to harness AR and VR effectively and drive innovation within their learning ecosystems. 1. How AR/VR enhances engagement and knowledge retention. Empirical evidence. A systematic review highlights that AR and VR significantly boost student engagement and retention by offering hands-on, interactive learning experiences that allow learners to take control of their educational journey and actively construct knowledge. Familoni Onyebuchi, 2024. A study on VR applications in anatomy education reported a significant improvement in knowledge retention compared to traditional methods, indicating that immersive experiences help learners internalize complex spatial information more effectively. Salimi et al., 2024. Additional longitudinal studies suggest that students exposed to immersive technologies maintain their understanding longer, show increased motivation to revisit learning content, and perform better in assessments than their peers in traditional settings. VR scenarios that mimic real-world environments have shown to increase emotional engagement, which is directly correlated with cognitive absorption and memory consolidation. Instructors also report higher participation and curiosity among students using AR/VR, suggesting these technologies activate deeper levels of learner attention and intrinsic motivation. Furthermore, immersive content often bridges the gap between theoretical knowledge and practical application, reinforcing learning through simulated real-life scenarios and iterative feedback loops. Business implications. Higher retention rates translate into better trained professionals, particularly in STEM, healthcare, and engineering sectors. These professionals are not only better equipped with theoretical knowledge, but also demonstrate higher levels of practical competency, decision-making ability, and innovation readiness. Institutions implementing AR/VR training programs experience increased student satisfaction, enhanced outcomes in skill demonstration, and reduced dropout rates. Learners report feeling more connected to the content, with AR/VR tools helping them bridge gaps in prior knowledge and achieve better long-term academic performance. Businesses integrating AR/VR in internal training report faster onboarding processes, stronger team collaboration, and a measurable uptick in workforce productivity. Employees are able to master complex systems more quickly, adapt to new roles with less friction, and perform tasks with greater accuracy and confidence. 2. AR/VR as a tool for complex concept visualization. Empirical evidence. AR overlays interactive 3D models on traditional learning materials, improving comprehension in subjects like engineering and biology by giving learners the ability to see systems in motion and understand spatial relationships in real time. Ivanova, 2021. VR enables experiential learning, allowing students to explore historical sites and conduct virtual lab experiments that simulate complex phenomena such as chemical reactions, human anatomy, and architectural construction. Shankar et al., 2023. Research indicates students gain deeper insights when visualizing processes in physics, medicine, or architecture through interactive models that adapt in response to user input, enhancing both observation and hypothesis testing. The ability to manipulate virtual components fosters spatial reasoning, a skill essential to success in STEM disciplines, and supports the development of cognitive skills such as sequencing, prediction, and abstract thinking. Furthermore, The ability to experience environments from multiple perspectives, such as microscopic, molecular, or cosmic scales, provides unparalleled opportunities for conceptual exploration and comparative analysis. These immersive tools not only strengthen conceptual understanding, but also build learner confidence and engagement by enabling safe, repeatable practice with complex or hazardous systems. These organizations often observe enhanced employee engagement and a faster transition from theory to hands-on execution, particularly in roles requiring high precision or compliance with safety standards. The use of AR/VR in higher education and workforce development enhances competitiveness and innovation by equipping learners with future-ready skills and fostering interdisciplinary collaboration. Institutions also report improved student recruitment and retention as immersive learning environments become a differentiating factor in program offerings. Organizations in sectors like aviation, automotive, and pharmaceutical manufacturing benefit from reduced error rates and higher task accuracy in VR-supported training. Three, enhancing accessibility and inclusivity. Through AR/VR empirical evidence, AR/VR supports students with disabilities by offering adaptive learning experiences tailored to different cognitive, sensory, and physical needs, thereby enabling more equitable participation in learning environments. Litvinova and Sirocco, 2023. AR applications facilitate multilingual education and support special needs students with assistive features such as real-time captioning, voice-to-text capabilities, and customizable user interfaces, fostering autonomy and confidence. Afnan et al., 2021. Interactive avatars and gesture-based controls enable learners with motor or visual impairments to participate more fully in digital lessons, while also allowing for eye tracking and voice navigation that promote independent navigation and content engagement. These technologies allow educators to create culturally responsive content tailored to diverse learner needs and backgrounds, incorporating inclusive visuals, localized language options, and narrative elements that reflect a wide range of social and cultural contexts. In addition, AR/VR enables personalized learning pathways, adaptive assessments, and immersive storytelling that respects different learning preferences and paces, reinforcing the role of empathy and inclusion in modern pedagogy. Business implications. Expanding AR/VR integration fosters inclusivity, improving educational equity, and broadening institutional reach by addressing systemic barriers and creating more personalized, adaptive learning opportunities for all students. Corporations can leverage AR/VR in diversity initiatives and corporate social responsibility programs by offering immersive training modules on unconscious bias, cultural competency, and inclusive workplace practices. Inclusive tech design can serve as a competitive advantage, attracting diverse talent, reducing onboarding friction for employees with varied learning needs, and demonstrating social leadership through equitable technology adoption. Organizations that embrace these inclusive strategies often experience improved employee morale, brand reputation, and community impact, reinforcing the value of AR/VR as more than just a technological innovation. It becomes a strategic asset for equity and social progress. 4. Overcoming challenges to AR/VR adoption in education. Key barriers: high initial costs. Development and infrastructure costs remain a primary obstacle. Boltikev et al., 2024. This includes expenses related to hardware, custom content, and licensing. Technical constraints. Effective integration into curricula requires faculty training, robust technical support, and alignment with institutional learning goals, Boyles, 2017. Additional challenges include data privacy concerns, software compatibility across devices, and the need for regular updates to maintain performance and relevance. Institutions must navigate evolving data protection regulations such as GDPR and FERPA, ensuring student information is secure when using cloud-based or networked AR platforms. Compatibility issues may arise between different hardware manufacturers, operating systems, or content delivery platforms, potentially limiting access or requiring costly adjustments. Furthermore, maintaining up-to-date content that reflects curricular changes and emerging technologies demands ongoing investment, instructional design support, and collaboration with AR/VR developers to keep experiences relevant, accurate, and pedagogically aligned. Business implications. Investment in AR/VR infrastructure, strategic partnerships, and educator training can mitigate these barriers by creating a sustainable ecosystem that supports ongoing technological integration. This includes leveraging public-private collaborations to share resources, reduce costs, and co-develop learning solutions tailored to institutional needs. Policymakers and institutions must focus on cost-effective solutions for scalable implementation, such as open-source content libraries, cloud-based deployment models, and regional AR/VR hubs that offer shared services. These approaches help lower barriers for under-resourced schools and promote widespread adoption. Long-term returns on AR/VR investments can include improved learning outcomes, stronger institutional branding, and alignment with digital transformation strategies. They also pave the way for innovative learning models, expanded reach through online immersive courses, and new revenue streams from AR/VR enhanced certification programs and lifelong learning initiatives. Conclusion: the future of AR/VR in education. The rise of AR/VR in education signifies a paradigm shift in how knowledge is imparted, retained, and applied in real-world contexts. These technologies are redefining the educational landscape by introducing experiential, learner-centered environments that promote deeper cognitive engagement and long-term retention. Collaboration between businesses, academic institutions, and policymakers is essential to overcome the current challenges and fully harness the transformative potential of AR/VR in both formal and informal learning spaces. As integration continues, future advancements will likely prioritize affordability, user-friendly design, improved interoperability, and seamless curriculum alignment that supports personalized learning at scale. Additionally, emerging innovations such as AI-enhanced VR tutoring, biometric feedback for adaptive experiences, and decentralized content ecosystems are expected to further accelerate adoption. Now is the time to strategically invest in AR/VR to cultivate a more inclusive, accessible, engaging, and future-ready learning ecosystem that empowers learners and educators alike.